Hello.
Hi, we're
Massimo.
live.
Nice to see you.
Yeah, nice to see you. I don't think we sort of met online before.
Yeah. I mean, we met
Definitely
on a call.
the first initial call, I think, right?
Yeah, it
Yeah,
was quite a long time ago.
yeah,
Yeah.
almost a year ago, I guess.
Uh-huh.
Remember this. I think you guys were the first the first substrate chain that didn't have the sort of like a plan to become a parachain eventually.
Uh-huh.
Correct me if I'm
Uh-huh.
wrong. Or definitely the first that we
Yeah,
like
you indexed.
came to know. Yeah, yeah. Well, yeah, yeah.
Yeah. It was a great experience using your tools and your
Thank
help.
you.
You
Yeah.
guys are awesome. Like you really try your best and help with all the questions we got.
Yeah, I
Um,
mean, I've seen the chat is a bit on fire lately. I wake up in the morning, there's like 60 messages and stuff.
yeah, now it's
Crazy
getting crowded.
as
It's
well.
going to be more
Yeah.
difficult. Yeah.
Yeah, I mean, I don't know. I don't think we have a plan for this, but
Mhm.
I'm actually, because of all of these messages, I sort of like lost touch with what you
Uh-huh.
guys are actually building with Subsquid.
Uh-huh.
I don't know if like, probably it is good for the audience as
Yeah.
well.
But you were doing some example, right?
Yeah,
For
yeah,
Reef.
yeah.
Yeah.
Then I can go into the details of maybe
Uh-huh.
what. Well, I can start with that, but maybe like let me
Okay.
maybe I prepared um, a screen. Oh, sorry, one second. I need to give permission and probably because in the beginning we had issues with the restream, so I had to. Oh, bummer! It's gonna tell me to quit and reopen. This is sort of like unforeseen. I'm gonna be back in a second.
Okay. I need to
Sorry,
get
because
permissions.
I changed the browser because we were having issues connecting, and now like I have never
Uh-huh.
used Chrome with the restream. Yeah, gonna be back in a second. Sorry.
Okay. Okay. Yeah. So I see some questions. And what's the advantage to integrate Subsquid? Like the big advantage with Subsquid is that you can easily deploy your own indexer with now that we have our own like source code that you can use. And I can share the repository here.
Um,
Where's the chat? Chat. These are just the questions. Let's see the YouTube.
so, can you see me now?
Yeah, I
Can you
see
hear me?
fine.
Yeah. Okay. Yeah. Okay. I'm back. I was trying to share the screen, and
Huh?
it's
And I'll post the our GitHub repository to YouTube, so it's gonna be easy to find.
okay. Yeah. Now it's back. So inception moment. Yeah, so I've prepared a quick presentation on Subsquid. I heard you were sort of introducing what do we do, how we've been helping you guys. So in a nutshell, basically, Subsquid is a blockchain indexing framework, and our SDK has a lot of flexibility embedded into it. It was built to try and sort of be like not teach you anything, just let developers do what they want to do with it. The purpose of this sort of demo that I'm going to present is to try and index or succeed in indexing the transfers of the Reef token. This is just an example, and the logic in it is very simple, but it's just to showcase the tool itself. But yeah, like just a minute about myself. Like my name is Massimo Luraschi. I'm a developer advocate at Subsquid. Here are my sort of my socials if anyone want to reach out and has any questions. And the reason for Subsquid to exist at all is because we believe that in order to work and be successful in working with blockchain, the blockchain itself is not enough. It shouldn't be necessarily used as the backend for all your dApps. What's referred to this sort of engineering practice is adding a middleware, and in this case, an indexing middleware in between the blockchain and your dApp. And what do we do with that? We sort of we are connected to a blockchain, yes, but we sort of act as the middleman. In this case, a positive one, not like the hacker attack. And we index the data, and we make sure that you can filter it and access it in a more performant way, so that, I mean, as everyone has ever experienced, directly accessing the blockchain, it's not the most performant and most efficient way, especially for everyone that has been used to developing in the Web2 world. So what we do is we ingest it, we provide the data processing framework, so you can customize and do whatever, sort of present it in however way you want it. So in this case, the data for transaction might be there, but it's just like unintelligible. Instead, if you pre-index it and process it in the right way, you can just ask questions and clever queries like, get me all of the NFTs owned by this person. The way we've done it is with a modular architecture. We specified, we sort of focused initially in the ingestion part. We have the equivalent of data lakes, which we call archives. And then we allow developers to develop their own way of presenting it for different purposes. You may want to just simply have a GraphQL API for your dApp. That's good. It's the basic case if you want to. But we also have developed the SDK to be open enough to allow for other use cases like analytics and data science. The difference in this approach with respect to existing solutions is that the monolith architecture basically has the same ingestion for everyone, even if you have multiple users on the same blockchain. And this has replication, wasted effort, and resources. It's also more costly because of the wasted effort. Instead, with the shared like data lake part and the modular architecture, the sort of like you save in performance, in cost, and everything. And it's just, I don't know, if you think about it, it kind of makes sense that you don't have to duplicate at least the initial raw data ingestion part for everyone, because also the blockchain in the end becomes the bottleneck. And the data flow, like I explained, you have the blockchain, we extract with the archive, which is this sort of like mini like cycle of ingesting, processing it into a database in a very raw but yet accessible format, and presenting it through a GraphQL API. And then you have your squid, which you can develop yourself. The benefit of this archive are essentially derived from the architecture. So it's one less thing to care about one less thing that you don't have to maintain as a developer, because the storage is specific to this use case. It yields better performance. It allows for filtering. It has, because of the filtering, it has less overhead. And also because of the batching, which was one of the major improvements that we introduced June last year. And the modularity allows for future improvements, which are already in progress, by the way. The squid, like I said, is the second part in this sort of like data pipeline. And it's the part that we actually build with the SDK. Its main component is the processor, where you define the logic of the data processing, and it also has its own database and the GraphQL server that comes with it. Whether you want to turn it on or not, you just because, for example, in the data analytics case, I have a few examples where I don't need not even the database. I save on CSV files, for example. That is sort of like the flexibility for that the SDK has to offer. So I don't need these two pieces, but they're there if I want to. And yeah, the benefits of the SDK, like I said, is the flexibility. There's a lot of automation from the models generated automatically from the schema. Then the automation of TypeScript, sort of like boilerplate code around the API or around the substrate types, for example. And the fact that you code and you don't just use config files that might initially be useful, but and sort of like provide a shortcut, but oftentimes do not allow enough sort of flexibility. And then the typings, I think speaking of typings, there's a typo. The typings of TypeScript allow you for more type safety. So when the data is extracted from the blockchain, it has its own specific types, and they are respected because the automated, like the automatically generated code respects them. And finally, one thing I think you were mentioning is the hosting service. So we have two things that you don't have to care about, and is the data source, the archives, and where you want to deploy the application. With Aquarium, you just with a one command, you just SQD deploy, and you have your API ready to go and public.
Yeah, and that's really great because we also now we implemented also the private route,
Oh
and
yeah.
yeah, so we can use it for some other um, specific applications that we really need to be functioning, so we don't get attacks on those. Uh, and so it's really also, we found a ways around to make it, to customize it even more. And we're doing the pulse as well. So Reef Swap is going to be indexed, and we're going to show all the graphs and the candles and things like that.
Oh, that's awesome.
Yeah, yeah.
Yeah, I try to like provide like a demo like that. It's just obviously when I create demos, it's like very simple, so it doesn't go into
Mhm.
the depths of
Yeah, yeah.
providing data for candles, but still,
Mhm.
it's very common use case. Well, common.
Yeah. I mean, we had
Intuitively.
to, you helped us to find way around it because the database uses views. Um, so yeah,
Oh
we had
yeah.
to, do some workarounds.
Yeah,
Uh,
yeah. So
but
the elder response on that, how you can create a view, which was not necessarily immediate in terms of
yeah,
like we don't have
yeah, yeah.
documentation about it, but yeah,
But yeah, I think it looks like we're almost there, and um,
awesome. Yeah, continuing on the presentation, just to give like a few quick examples of what I meant with the, for example, the automation. You define the schema. In this case, you say you want an entity called owner, which has these three fields, and you just hit a command that will automatically generate a TypeScript class for you that basically defines the TypeScript version of these fields. And this is used as an ORM, which is sort of like the database abstraction layer for TypeScript. And you basically just say owner store write the owner class, and we just save it to the database. The same thing goes for the ABIs. For example, when you have a smart contract, you have your ABI in a JSON format, which defines all the inputs and the events and types. And by hitting a command, you generate functions that define the same thing, just in a TypeScript format. And you can use it like this to access the approve function and decode the input that comes from the blockchain. One last thing that I was mentioning is the aquarium. You just need the CLI and SQD deploy. Every repository, or sorry, every project that you create with a template has its own manifest, which is a configuration file for the deployment. And with SQD deploy, just execute it essentially. Here's a list of resources that we have. The first and foremost is the doc site. And then if you want to browse around the Subsquid organization, I myself am creating content on our Subsquid YouTube channel to try and provide more and more examples of possible use cases. And finally, Matthias, you were describing the relationship that we have with devs and how we try to help them. We have our private chat with you guys, of course, but there's also like a common overarching devs chat, which everyone can access. It's called, the link is Hydra Devs because that was the old name, but now it's called Squid Devs. And this is where every developer can just ask questions. We try to be very responsive. Yeah, the same content that I post on YouTube, it's also on Medium as an article. If we want to get coding and start with the example, I don't know if you have any comment, Matthias, but otherwise I'll just get going.
Yeah, okay, great. I'm just sorry I muted because I have a neighbor with a chainsaw.
I could hear it from time to time.
Slovenia was the greenest country in Europe, but now it's not anymore.
Your neighbor is cutting it all down.
Yeah.
Okay, just real quick, like I said, the goal is to create a Reef tracker, so a tracker for the transactions on Reef. Like I said, I actually, on the logic part, I took a very quick and dirty approach, and it's just to show how you can sort of crunch the numbers a little bit, even though the result is completely misleading. It's just I have negative balances because, of course, I'm just indexing one event that impacts the wallet of someone, but there's multiple. There's like staking, there's the initial endowment when you create a wallet, there's whatever. So obviously it doesn't make much sense. It's very reduced in the scope. But we start from the setup, how to create a new repository, review the schema, change or recreate the substrate types. We go through the sort of like the automated process that I described. This is where you actually have to like putting the work yourselves. And then finally just launch the database container, launch the processor and GraphQL file. Starting with the setup, I'm gonna keep going back and forth from this to my IDE so we can just do it together. The requisites are Node.js, Docker, and Subsquid CLI, which maybe I can show in a second. It's here in our docs. There's a whole section about Subsquid CLI where you can just install it as simple as using Homebrew or NPM. That's it. I already have installed it, so we sort of skip this step. Let me start fresh. This is the final product, sort of what we're gonna hopefully achieve by the end. Let me open a new window and let's start. So the first thing that we said we're going to do is use the SQD command, specifically the init, to start a new project. And it's going to ask me what kind of project I want to build. There's a mini questionnaire, what kind of template. We have EVM, because we're multi-chain, we also index Ethereum and EVM, pure EVM chains. So there's this template. Don't be sort of fooled, because Reef is a particular case. It's actually the frontier EVM, because it's a substrate chain that has a frontier palette that allows the EVM compatibility.
Yeah, not exactly frontier.
Well, yeah, sorry.
I mean,
but
we have our own.
The same principle.
It's similar.
Yeah. Yeah, we probably should rename it. We try to give it a meaningful enough name to make it distinguishable, but yeah, not specific enough. I don't know. Maybe we'll see. Substrate EVM is good enough. And then we need to install the packages, of course. So let's go. Yeah, it does have an environment file. One thing that the template doesn't have, and actually let's open it really quickly. Reef transfers. Yep. So this is what a basic template looks like. It has, first of all, the Docker Compose, which is the database that I was talking about. It has the schema, which is where you define the database structure, the tables, or the APIs that your GraphQL will expose, the queries that your GraphQL API will expose. And this is the manifest that describes the deployment that you can do on a query. The next thing that's quite important is the processor, sorry, this one, where you instantiate the processor class, which is in charge of connecting to the archive, requesting the data, and then it has this nice callback function, which is where you can define your own logic. It also, obviously, you can, like in this case, you can call external functions and define whatever you want to. Obviously, as the project gets bigger, you want to give it a more refined structure. The other thing in here is the models, which because this is sort of like both a template and an example, it has, like you see, its own schema, and of course the models have been pre-generated. So because we have a transfer, contract, owner, and token, we have this stuff right here. Come to think about it, I actually, on this example right here, I started from the opposite. I was doing a substrate example, and I added a frontier sort of EVM part. I'm doing the opposite. I'll see if it works. If not, we're going to have errors at the end, just because maybe I missed some steps. But we'll see. I think because this is already an EVM project, it might already have frontier. Nope, here. Yes. Also, I always forget to zoom in a little bit. Okay. So in the schema, we want to change it to make sure that we have a, actually, let's do, because of the schema, we have steps that don't make sense because of what I just said. So let's do it differently. We go back one step and say, so yeah, just to be clear, because Reef has both the substrate part and the EVM part, in this project I'm indexing both, but however, like sort of the end result should not depend on where you want to start. If you start from the substrate and add EVM indexing, or you start from EVM or and add substrate, it's just that the guide, sort of like the walkthrough that I made, follows one path, and it just doesn't make sense if I do otherwise. Okay, so there we go. Just CD Reef. Okay. Yeah, so it has the same structure as I showed you earlier. The only thing that changes actually is the processor, which is indexing an event rather than a smart contract, and the schema. Because it's indexing balances, transfers, it's much closer to what I want to obtain in the end. That's why it probably is better as a starting point. Like this page says, we already have a good starting point on the schema side. We just want to add a balance field and a contract entity. So the balance field goes here, and it's a big integer. Yeah. And we add this one. So that's good. Yeah. When we launch this command, we should see that the generated folder changes, and I have a new contract file. There we go, which is exactly what we define in here. Moving on, like I said, we automatically generate code starting from some configuration file and some information. And this code, in this case, is for the substrate part. We basically have every information about the types of Reef chain stored on the archive. And the archive knows every time they have been changed. For example, when the balances transferred has been changed through a runtime upgrade, we know about it, and we can download that information and generate classes that are aware of these changes. So let's go and change this file with, hold on, I'm going to show what's in this link. We have an archive registry that's it's what we use actually in the code to connect to archives, and has this the endpoint of the archive, and it's what we use to download the data right now. So typegen.json here, the basic project is connecting to Kusama archive, and it's indexing balances transfers. What we want to do is substitute with the Reef chain and regenerate types, because it already has its own here. It's just these are for Kusama chain. So obviously it's a different story. I think balances transfer have been changed quite a few times. 1, 2, 3 runtime upgrade have changed the structure. In this case, you can see that it has 3 fields. There are 2 integer array and a big integer, while initially it was, for example, 4 fields, because it has the fees embedded in it. So when we do this, sqd typegen, you can see that the class has been changed, because I think you only had one version, which is v5. This is sort of like a bonus thing that I was wanted to try and do, which is matching the substrate address with the EVM address using the storage. I'll see if we have time in the end. It's kind of like a cool thing where you guys have this possibility to reserve the how do you say it? Like, it's not reserved, but basically it's to alert the blockchain that, hey, I'm this address on the substrate side.
Yeah.
And actually,
you bind the EVM to the EVM layer.
Yeah, exactly.
Yeah.
I kind of wanted to do that, but let's see if we have time. It's basically, well, actually, let's do it. Why not? So if I want to add this, it's simple enough as adding this to the storage, meaning I want to also know how this specific storage information on this storage palette has changed throughout the history of the blockchain. So I regenerate sqd typegen, and now I should have not just the event file, but the storage, which is defining how many times. Just the one. We'll see if we'll use it in the end. Next, I want to do the similar thing, but with the contract API. Like I said, we basically are able to read the input output from the interface of the contract and generate TypeScript wrappers around it. So we go to the contract. Luckily, you have a very good explorer that has this data. I can go to the API, copy, and paste it here, and say it's actually.
Yeah, but maybe Reef is a bit special. Otherwise, it's ERC20 can be used as well.
Mm-hmm. Just to, well, I think everyone should be familiar with what it is, but let's say transfer. We are specifically interested in the transfer event, which has these 3 inputs, and this is what we are going to index. So the who's sending to who and how much. And one thing also I wanted to show is the comments.json, which is basically how we are able to extend the sqd command line by defining your own custom comments. A lot of the stuff that I've been using right now is actually defining here. So if we take a look at the typegen, it's actually calling a sort of a subcommand defining our libraries. It's just providing a nicer, much shorter interface. And by doing this, I'm adding a typegen EVM, which takes as input the JSON file and creates stuff in the API folder, which doesn't exist right now. So let's do it. sqd typegen EVM. Oh yeah, I forgot to provide the name of the JSON file. Stored in the wrong position. Yeah. Where is it? Hmm. Hold on. Yeah. Should be good. Oh, yeah, that's why. Because it's expecting it to be in the dash ABI. Sorry. No. Let's try like this. Okay, so that's a bit odd. Oh, wait, I think that's because I didn't install the correct package. Yeah, so it's not complaining about the file; it's complaining about the missing library. That's my bad. So we need to install. I was missing something from the presentation. I think I need to install Subsquid slash. Let's take a look at the actual package name. Yeah, this one. Sorry for the delay.
There's always something.
Yeah, right. Because it shouldn't matter actually where the file is because I'm providing the location. So yeah, okay, good. Now in the source ABI folder, we have essentially wrappers or boilerplate code around the ABI, which makes it possible to decode the on-chain events and decode sorry, not decode, but use the inputs to filter down the on-chain events, and also actually some APIs to communicate directly with the blockchain itself. So the events in this contract are the approval and transfers and transfer, and we have the types that are encoded in it. And as far as function goes, we have all of these available, and the contract class is what we are going to use, for example, to extract the name, symbol, and the total supply of it by directly communicating with the blockchain. This blockchain communication is actually slowing down the indexing, but because we're only doing it once at the beginning of the indexing, we're saying, oh, do we have a contract on the database? Yes, no. Okay, then I need to create a new one. Let me fetch this information from the blockchain. It's only done once, so it's okay. When you have to, for example, get a token URL from the for each token in an NFT collection, that can be very slow. So it's better to use, for example, a multi-call contract to do that. So you basically batch multiple requests into one single blockchain communication, and it helps with the efficiency of the indexing. So now that this is done, this is, for example, oh yeah, this is actually a workaround that I asked in the chat. I did not know, and I'm going to ask to the team why it's necessary. It seems like you have a different, different arguments necessary to create an ETH call, maybe because you have a custom
Yeah, exactly.
frontier.
That's the call to the ETH layer, basically.
Yeah,
on chain.
I'm not. Yeah, if I type ETH call, this is. I'm not sure if we are able to do anything like on the immediate, or for the time being, maybe it's something that we're gonna put an asterisk everywhere and say for Reef chain, just remember to do this. What I've changed here for everyone else is just these arguments right here. They're slightly different. This is what is automatically generated, and this is what actually it's needed. So the argument themselves are okay. It's just it's missing a second argument, and it's missing a sort of like a padding of the address, I think. Feels like. Okay, moving on. We already have a contract handler, or I think we don't. Oh, no, we don't, because it's a very simple. Oh, because it was a substrate project. Usually, every EVM template has one. It's like you said, contract handler, just creating a singleton instance for the contract itself. So let's go ahead and create a file. Oops, in here. Let's basically import what we need. First of all, the contract API that I mentioned, and then the context from the processor and the contract address. Some of this stuff might be missing. I'm going to adjust on the fly. Yeah, for example, we don't have the ethers library. Let's add it. Yeah, we under the hood, when we communicate to a contract on chain, we actually use ethers library for now. But that's part of the modularity. We're looking into a different library that is supposed to be more lightweight, and we'll see if it's actually a valid option. We're going to substitute it. This is what we want to import. Yes, okay. And I'm going to create this function, which is called create contract entity, which is doing the communication, the part that communicates with the blockchain. It's instantiating a contract API, and then it's trying. It's surrounded by track edge because you never know the like for some reason the API can fail, and you want to handle it nicely. But otherwise, it's just using the contract API to invoke the name, symbol, and supply functions. There we go. And this other function is handling a singleton, this right here, which is basically going to cache, act as a cache for the contract model, contract entity itself. And so if this is null, the first time we call it, is going to try and see if, for example, we already index and just stop the processor and restart it again. That might be still in the database, so we try and fetch it. If not, we just go ahead and create it ourselves using the other function. So in totality, this is what the files look like. We define the contract address as a constant. This is the function that does the blockchain communication. And this is just saying, do I have a contract? No, yes, and no, whatever. Sorry, as far as the processor goes, we are doing okay. We just have to obviously adapt to the fact that we are not indexing Kusama, we're indexing Reef. So let's go ahead and change it right here. This is the library that I was talking about earlier. It's used to fetch the URL of an archive for a given chain, and it like I can show you to you here. It's using this JSON file to essentially doing the lookup. So when I say lookup archive Reef, it's just going to say, okay, I need this data source, and this is the URL. We are, like I said, we are indexing the event balances transfer, the transfer event of the balances palette, but we also want to add the EVM log of the Reef smart contract. This is essentially to show everyone that you can do even both substrate and EVM on the same project. It's gonna miss imports. Let's do it. No, not this one. I want the events from the ABI. Okay, and then like I said, the logic is very simple. It's rough and inaccurate, but I want to add the fact that if, for example, there's a new account and the balance is 0, of course, because it's new. Since it's trying to send data, I'm going to log a warning. We're going to see a lot of warning because I'm missing the fact that the account can be endowed with money from the start. And so the value 0 is actually hard-coded in my case, which is not real. The other thing that I'm doing is, for example, from the balance, I'm subtracting the amount sent and the fee, which is basic accounting. Of course, like I said, it's not complete because it's not taking into account all the other things that impact a wallet account, a wallet balance. And I'm doing it in this, in this part right here. Sorry, where are we? Let transfers. Here. So here's when we process all of the data that is extracted from the events. I'm going to show it to you in a second. But whenever we decode the two addresses, the from and to, we try and see if they are in the database. And so we update the logic to what I showed you. I think at this point it's better if I just go through the rest of the file before making even more changes. So like I said, we are configuring the processor to connect to the archive and eventually to the chain when needed. For example, when we connect to the smart contract or when we access the storage. Otherwise, all the rest of the data comes from the archive, because it's much more performant. And then we say, I'm interested in this event from the Subsquid part, and I'm interested in this EVM log. And then the process is launched by running the run function, and it's going to start creating requests towards the archive in batches. And whenever the archive sends back like a bundle of data, this callback function is invoked with a context. And the context contains, first of all, the store, which is because we, it basically is the way we instantiated the batch processor by creating this store, which is an abstraction layer towards the database. It's useful to save the data in the end. And it's also containing, I think it's visible here. It's also containing all of the blocks that have been found in this batch. So basically, let's say I'm requesting all of the data possible to the archive. The archive saying, slow down, I'm not going to give you all of them because there are too many. So I'm going to send you like 10,000. And it's also telling me these 10,000 are actually contained in like 5,000 blocks. So I'm receiving 5,000 blocks, and each one of these 5,000 contains some items, a number of items, definitely more than one, otherwise they wouldn't be sent there. And so I'm using this double for loop to process each item, which in this case can be either a balances transfer event or an EVM transfer, which is part of the logic that I'm going to have to add right here in a second. But I wanted to show you like the whole process before doing any more changes. And then when I identified what kind of item it is, in this case, I'm using the interfaces that we saw earlier, the types right here. So if we go here, we're going to find this class, balances transfer events, this one. And like I said, this is aware of the changes that have occurred to the balances transfer event. And it knows, for example, the structure and the types. So it knows that it has 3 fields. The first one is the sending address. The second one is the receiver. And the third one is the amount. And this is exactly how I'm treating them. In this case, it has errors because it's still using the functions defined by the previous types, but we have regenerated. So this is one of the corrections that we have to make, which is using the new function and say, that's it. These are not necessary anymore. And so now it's happy. And then with the processed or extracted data, I'm able to create this sort of transfer event interface that I defined myself and say, okay, For a single transfer, I want to store, well, an ID, which in this case is the event ID. Then I want to store the block number, the timestamp, the hash of the extrinsic, the two addresses, the amount, and the fee, right? And all this information is contained either in the item itself or, for example, in the block. Once all of this is packaged and sent back, returned, because this is returned, I'm able to, and we're here, right? And I'm able to process it and sort of do some maybe data conversion and prepare it to be saved on the database. So, for example, here, all of this processing is done to find all of the accounts that are already existing on the database to either update them or create new ones. And then for each item in the list, for example, I'm trying to get the already existing account. Otherwise, I'm creating a new one in this function right here. And then it's creating a new transfer model, which is defined here, and it's derived from the schema transfer. There it is, one of these. And it's just simply adding the right information in the right place for it to be instantiated. And then what it actually is doing is creating an array of all of these transfers. And it's not saving them one by one, it's rather saving them all at the very end. This is once again to increase the performance. This is all already good for what we're doing. I chose a project that is actually similar to what we already have in the template. But like I said, I'm going to have to make a few changes, and we already have gone through a couple. Like I said, the next one, I already done it, which is adapt to the types specific to the Reef blockchain. And the other thing that we need to do is use the correct codec, for example. We provide libraries to encode and decode substrate addresses. But for example, here we were using Kusama, and this is not correct. You use substrate addresses instead. Substrate. This part is good. Next, we're completely missing the EVM part at this time because the project was simply configured or developed to index the substrate part. I've added the EVM, and I've configured it to, like you see here, to request data about a specific EVM log, and this is how we process it. I'm going to copy, and then I'm going to explain it. So like I said, I'm looping through all of the blocks and all of the items received. But at this point, I don't know what kind of item I'm looking at. Luckily, I have fields that help me in recognizing it. In this case, I'm saying, is the item name balances.transfers? Then, of course, I'm looking at a balances transfer. Instead, if the item name is EVM log, then, of course, I'm looking at the EVM log that I requested. But I can do further checks. For example, I can say if item.kind or item.kind equal, and it's actually auto-suggesting. Because, for example, I could request not just logs, but transactions. And I can also check the topic as well. If I'm requesting multiple logs, I can say, is it the smart contract 1 address, is it generated from smart contract 1 or generated from smart contract 2? Is it generated from this the transfer topic or the approval topic, for example, from the same smart contract? You can do all sorts of checks. For example. The get EVM log function doesn't exist at the moment, but let's imagine that it is. We're going to build it in a second. And once we have the extracted EVM log, oh no, actually, this is imported. My bad. This is imported from the Frontier, I think, package, which I'm not sure we have installed. Yeah, we haven't. So npm I. So we should be able to find it. This one. This function doesn't do magic. It actually sort of is a workaround. It says it doesn't exist, but I just installed it. I think VS Code is having a moment where it is not catching up to the installed libraries. But what this does is, oh damn it. What this does is actually checking that the event name is EVM log, and it's basically a workaround because some of the Polkadot chains have changed where they store the event. It's either as the argument or as the log inside the argument. So we basically added this wrapper so people don't have to break their heads. We should be good. Yeah, sorry, actually, let's not gloss over it. Maybe spend one more moment on this one. So once we have the EVM log and we're sure that it is, what this is doing is using the TypeScript boilerplate code that we have generated from the API to decode the transfer event given the log. And it's providing the input contained in it. If we want to take a look at this, it's imported from, where is it? Events from the Reef API sort of TypeScript counterpart, however you want to call it. And it's here. So it's using this function right here and this interface that is a generic log event specific to the types provided by the transfer event, which is exposing the fields, and I can use the function defined in it to decode it. This is internal libraries from Subsquid. I'm just showing you basically, I'm going behind the curtains a little bit to show how things work. And yeah, and then it's doing a very similar thing to what we have done here above. So this part is the EVM equivalent to this part, right? If you want to look at it this way. And then this is essentially the same thing. So we're creating a new transfer object, which we're pushing to the array, and it's going to be part of the array that we return in the end. Now, when it comes to the database, like I said, we obviously need a place to store it. Subsquid provides a sort of like an abstraction layer, and the template comes with a Docker Compose file. So we just need to use the CLI tool to just say sqd up. Obviously, as we said, there's probably something already running. I think I was preparing for the workshop and I gave it a dry run and I forgot to, oh yes, I forgot to stop everything. Okay, we should be good. Because I didn't just delete the container, I deleted the image. Now it's downloading, of course. Okie doke. As I said, we have a sort of like an abstraction layer that takes away a lot of the sort of complication of managing a database. And one of these is, of course, creating the tables. We have tables in here, not tables, but migration files, which are basically in charge of being of creating these tables when executed, and they contain the definitions of the SQL queries that needs to be done. None of this should be necessarily manually touched because they are automatically generated, and they are they can be also incremental. Incremental. Sorry. For those of you who use any other like frameworks such as, I don't know, I've used Django in the past. Migrations is a very familiar concept. Because it already has its own tables. The best course of action, we have a fresh database. There's no need to use this one. It's probably better to just delete it and start from scratch. So what we can do is do sqd migration. generate, which actually regenerates all the migration. It deletes that one and creates a new one. Looking at the database status, which migrations have been already applied, if any, and the schema that we have defined. And it's making sort of like the three-way comparison and say, okay, these are the diffs. This is the operations that I actually need to apply to obtain the final status, which is a new migration file that has very similar stuff. It just has the new, I think, contract, right? And the new balance field, which the previous one didn't have. And then we just launched the process and launched the GraphQL server. So let's start with one. This is going to, first of all, apply the migration. Can a mix begin with other? Oh, damn it. This is a new one. It's very odd. So we make two weird demo day things in a row. Honestly, I'm not sure. I guess it's not happy with the big integer here. Where? Here. But it's kind of weird. I'm gonna check and maybe let you guys know after the workshop. I think we can launch the other one. I'm not sure what I basically followed. Let's try and execute this one and see how it goes. It should be the same. They have the exact same schema. Yeah. Yeah, of course. I need to tear down the database first. Sorry for the confusion. I hope you're following. If not, just maybe give me a ping. Okay. Yeah, like I said, I'm gonna dig what the actual meaning of that error is and let you know. It's the processor is doing what I described. So it's following, like it's launching this file, this compiled file, instantiating the processor, launching it, and then it's just a permanent loop. It never ends, essentially, unless it errors. And every time it's receiving one of these contexts, it's basically one of these lines right here. So it's telling me essentially some useful information about the mapping speed. Like you see, we're indexing roughly 8,000 blocks not 8,000 items per second, 71 blocks. It depends on the density of the event itself, of course. And like you said, it's complaining a lot about negative balance. I was sort of expecting this, of course, because like I said, it's not a complete project. This is blocking the terminal. So if I want to launch an API, like the GraphQL API, I need to launch it separately. So SQD serve, which is to sort of serve the GraphQL server. And like you say, like you see, it's exposing the port 4350. Let's go to a browser. And I think I need to zoom in a second, but also I want to highlight that this is, okay, localhost on the port 4350, but it's also /GraphQL. Otherwise, if you just do localhost 4350, just not responding. And these are the queries that are derived from the schema. So there's the base queries, which are the entities we have defined. So transfers, contract, accounts. But there's also account by ID, account by unique input. It's just like they're automatically derived from it. And there's also one cool thing is the, which I often use, is the connection, which has the counter. So for example, I can see how many total transfers I've indexed so far. So even though it's not finished, I don't think it has. Let's see. Yeah, I think it has caught up with the chain. But even if it didn't, the data was there. It's just, it wasn't complete. so far we have indexed very quickly 99,000 transfers. Um, and it also has the status, which is the height of the chain. So you can check whether, for example, you can use this for if you have the API deployed in production, you can just use this endpoint, this query, to check whether you're behind the blockchain or by how much. You can expect a few blocks, like maybe in the realm of 10 to 20, maybe. Depends on a few factors, but I think 10 is a reasonable amount.
Yeah, but also you're preparing the unfinalized block or not?
Yes, we're also working on that as well. It's not ready, but we're like it's forecasted by the end of March. So
Mhm.
yes.
That's great. At the moment, there's 3 blocks behind because that's the finality.
Okay. Okay.
And yeah, that's gonna be great to show the live live data
Yeah.
from the chain.
Yeah, yeah, yeah. I think that to correct myself, I think it's by the end of March for EVM,
Mhm.
like pure EVM chains like Ethereum, Polygon,
Mhm.
etc. Probably a couple of weeks later
Okay.
for Substrate, just
Uh-huh.
because they're two separate sort of generation of archives.
Uh-huh.
Um, and yeah, like I said, I can show you the, for example, the accounts and the balance, but obviously it's not going to be pretty because the math there is not correct. And this is a GraphQL API, so you can do whatever you want. Let's say we ordered by balance. So, I don't know. Yeah, this one is saying -6, and it goes worse than from there. Um, I think yeah, it's mixing up the ID in terms of the EVM address and the substrate address. They're sort of used interchangeably. But if we were to use, for example, the storage um, that I was talking about earlier, like this one, the EVM account EVM address, this is where uh, you can
Yeah,
do the
resolve. Yeah.
yeah resolve. Yeah, exactly.
Mm.
Let's see what's next. I think, yeah, this was it. I'm very sorry about the hiccup here. I think I saw a similar thing on Discord and I didn't dig deep enough.
Mhm.
And obviously it hit me live. um, I think the point here is I hope I did a good enough job of showcasing like what you can do with it, what the SDK is capable of, and then you obviously it's up to the developers. So pick a contract or any other like pallet event transaction, whatever, and just do your own thing. Um, like the slide said, we just inject the blocks and extract the data, and then it's up to developers to decide what they want to
Mhm.
do with it.
Yeah. And we also saw how fast it is because it's using the archive and getting like the batches of data. That's really
Yeah,
great.
yeah, yeah. One of the things that the positive thing that using this the storage could have done is show by how much using the storage could
Uh-huh.
slow down the indexing, because obviously for each of the addresses, let's say, found in the um, in a batch, I would have to do like communicate
Oh,
with the blockchain and
yeah.
request the correspondence, and that would have slowed down massively uh, the indexing. Sorry.
Yeah, yeah. But if you have just some simple things,
Yes. Yeah.
that's really fast. Yeah.
Yeah, yeah, and like I said, we already are actually like here to show better. Um, I think we are. Oh no, I forgot to add a one. No, I used this one. So we're executing the correct code. There was one missing piece, I think, which is this one. Here at the end of the batch, when we save everything, I was using the get contract entity function, which we
Mhm.
define in here. So I was actually communicating with the blockchain, but just once. So because of that one single request, we didn't even see it. We didn't even notice the performance degrading. But if we multiply this by like 1,000, for example, per batch, obviously it starts to quickly be noticeable.
Hmm. Yeah, I mean, we're getting balances for accounts, and
Mm-hmm.
also we optimize that. We do that at the end of the history index,
Mm-hmm.
so we don't request from the chain for every block.
Yeah,
So this
one thing
optimization.
I just remembered is also that there's not this one, the storage. The storage has sort of like an embedded um, multi-call. The EVM contract has have
Mhm.
sort of MakerDAO has created this wonderful thing, which is the multi-call contract, which has the aggregate functionality or function. And actually, Substrate goes beyond that by using the get many or get all
Yeah, yeah,
functions on the storage.
that's great.
So this is,
Mhm.
yeah.
Yeah, that's,
Yeah, basically we're getting to we got to the end
mhm.
almost unscathed. And if you want to give it a quick look to the SDK and follow the repository, give it a star, go ahead. Yeah, this was the bonus thing. I think we're running late.
Yeah.
Yeah.
Yeah, and if any projects want to use our source
Mhm.
code and just deploy their squid and remove the stuff they don't need, it's also in the comments I posted earlier. So it's really a simple way to start. Maybe it's a bit more, it's a project where we do everything. So you would need to remove a lot of things if you're just using contracts, and probably it's easier if you can do just the way that we did right now.
Mhm.
Um,
Yeah,
yeah.
we have plenty of templates. There's
Mhm.
a separate organization on GitHub which is called Subsquid Labs dash
Mhm.
Labs, and it has plenty of examples. I think all of the material that or the content that I create for YouTube is the end repository, final repository is stored
Mhm.
there as an example. So there's a lot of like probably simpler stuff that
Yeah.
the developers can use to start from.
Yeah.
Yeah,
Great.
I took a look at your repository. It was quite big, quite
Yeah,
complex.
we are trying to index everything.
Of course.
I mean, most of the things, and just for simple things like the contract events and stuff like that, it's easier to do it from scratch like this.
Yeah, yeah, yeah.
Yeah. I mean, great. I'm
Awesome.
very happy to get your support. It was very helpful throughout the um, development.
Of
Yeah.
course. I mean, we really try and like help developers succeed and
Mhm.
use. We also like on the other hand, we receive a lot of feedback, and a lot of the improvements that we have made have
Mhm.
been done by just talking to devs,
Mhm.
either in private sort of like one-to-one chats with
Mhm.
the teams or in the common developer chat. So
Mhm.
yeah, it's awesome.
Yeah, great. And it works great. So
Thank
also
you.
like the deployment is
Yeah,
it's
which I
cool.
haven't shown. Yeah.
Yeah, you can do it in one line, and you spin up the new squid, and
Mm-mm.
yeah, it's really nice to use.
Yeah, I encourage everyone just watching the document, like looking at the documentation. There's a whole section about deployment where there's a lot of useful things like
Mhm.
variables, secrets.
Mhm.
There's the sort of production unified URL so that you can have multiple squids and
Mhm.
just substitute which one has
Mhm.
is using the production URL.
Yeah.
Yeah, I think we maybe have to wrap it up a little bit,
Yeah.
but thank you a lot
Cool.
for
Thank
having
you
me.
very much. Great to see you, and
Yeah, you too.
we're in touch.
Yeah, let's keep in touch and good luck on like using Subsquid, but everything else as well
Mhm.
on Reef
Yeah.
Chain. I hope you guys succeed.
Thank you very much.
Thank you.
Have
Have a
a nice
good
day.
one. Bye
Bye
bye.
bye.